eve of the World Cup final. Go France, I guess. Go for a competitive game. Go for a shootout. Now, y'all, we're looking for a natural number solution that is z plus, means positive integers, numbers like 1, 2, 3, 4, 5 ad infinitum. Now, this is an odd-looking expression. It's an equality. It's a rational expression where you have variable base, variable exponents, both in the numerator and the denominator. Now, since you are given this fairly big hint that there is a natural number solution to this expression, you may want to consider the prime factorization, which is what I did down here. Now, before we get into that, notice from this step to this step, which may not even be necessary, is that's just based on the fact that root 54 is equal to 3 squared, the square root of 3 squared times 6. Okay, let me write that down. Not that you really need to see that. I'm sure you saw it. But this is equal to the square root of 9 times 6, and 9 as a prime factorization of 3 squared. So that's 3 squared. 3 squared times 6 there. And so that's what happened going from this step to this step. The square root of 3 squared is certainly 3, so you have 3 times 9, which is the 27 you see there, and the 6 is left. Okay, now again, we went ahead and broke it down into its prime factorization, where this is a reduced fraction as much as it can be reduced. This is an irrational number, but there are no common factors in the numerator and the denominator, so it's reduced, which I think turns out to be useful. Now, I just set it all back equal to what we're trying to do here. So let's move on down. Now, okay, folks, so all I'm doing is I just recopied this to here. Now, what I did right here, and again, a lot of this you can see, I'm sure, probably doesn't require a whole lot of explanation, but notice that inside here, this is the square root. You can factor a 2 out of the radicand, okay, which makes it a 4 on the exterior, okay? Whereas this would be 2 times x plus 1 right here, so if you factor a 2 out of the radicand, you get the 4 right here. And so you see what would happen right here, just this part right here would be 4 raised to the x times times the square root of x. Let me just write it. I think the parentheses help quite a bit right here. So we have the square root of x plus 1. Raised to the x power. Okay. Now that explains this funny looking little step that you see, or it's this piece right here by laws of exponents is 4 to the x times the quantity square root of x plus 1 raised to the x. Now it turns out, in my opinion at least, the 4 to the x comes to the top. This is just a property of exponents, right? 4 to the minus x is 1 over 4 to the x, which is what it would be if it was down here in the denominator, right? Now what's cool about this, or what I like about it at least, is that this is a reduced fraction, right? So why can't we just equate numerators and denominators? We know x has to be a natural number, and let's just see where the chips fall. Now notice right here that so what I'm going to do, folks, is equate this denominator right here with this with 343. Now notice that 343, let me write this down here. Let's see, 343 is equal to 7 cubed. We already know that, right? But something else that's kind of nice about this that makes the answer just kind of pop out here in just a minute. Okay. Notice, though, you can rewrite this. You can rewrite this as the square root of 7 quantity q, or just, yeah, I'll just write it. I like the print. I mean, maybe not the parentheses, but anyway. All right. Okay, so notice what happens right here if we equate this denominator with this denominator, okay? Now we get equals to, it's almost an inspection sort of thing at this stage. You can see it, I'll just write it down, but we'll write down the square root of x, the quantity x plus 1 raised to the x power, right? Now you can see exactly what's going on right here, right? This is the square root of 7, all right, raised to the 6th power, right? So you see how, this is the square root of, so I made a mistake right here, sorry. Let's erase that. That needs to be to the 6th power. Okay, so that needs to be to the 6th power, right? Sorry about that, folks, because this is 7 to the 1/2, right? 7 to the 1/2 times 6. You multiply 6 times 1/2, and you get the 3 right here, just properties of exponents. But it's just the truth arithmetically, right? 7 cubed is equal to the square root of 7 to the 6th power, just arithmetically. But notice that by inspection here, that leads to a very favorable outcome. We can just tell by inspection that x must equal to 6. Okay, again, 6 plus 1 is 7, and then the 6 goes right there, right? Now, and that turns out to be the answer. Now, you may think, is this enough? I think it is, because this is a reduced fraction, okay, and you've been given a clue that that there is a natural number solution. So you found x equals 6. Now, a lot of you might not, and maybe I'm wrong. Maybe you need to check, but we'll just come down here and check if you don't believe, if you don't trust that. If you do x equals 6 right here, okay, if we take our x equals 6, I really think we're already done, but just for sake of completeness right here, this would give you the square root of 6 in the numerator raised to the 7th power. Okay, and then downstairs, if you put 6 right here, don't we get 14? 2 times 6 is 12 plus 2 is 14. So what we get right here is the square root of 14 raised to the 7th power. Now, I'm not going to do all this because it's a fairly easy check. Or wait, what do we got here? To the 6th power. I keep making that mistake. That should be to the 6th. Okay, that's raised to the 6th power right there. Now, let's see, we can break this apart in a variety of ways, but probably the simplest is just to write this let's see, that would be the square root of 6, so that would be 6 cubed with a root 7, with a root 6 left over, right? So you'd have 6 cubed times root 6, right? 6 cubed times root 6. And then down here, you would have, this is 7 times 2. All right, so how would that work out? That would be 7 cubed over 2 cubed, right? Okay, y'all, but you see how, I'll just keep writing. Okay, now what's going on right here is this 2 cubed, there's a 2 in here, right? So the 2 cubed here will cancel with the 2 cubed here, and you'll end up with 3 cubed. 3 cubed root 6. Over 7 cubed. Okay. And y'all, if you take a look back, let's see, I've already forgotten but let's see, over 7 cubed. Yeah, there you go, folks. 9 root 54, and right here, that reduces to 27 root 6, 343, right? 27 root 6, 343, and is that what we got? Yeah, okay, 27 root 6, 343, right? Which is, again, sorry I'm not on the same screen, but that's a problem I'm never going to solve, I don't think. So we got, this is 27 times root 6 over 7 cubed, which is 343, and that is what's going on here with our problem, right? Okay. So anyway, folks, that's all. And again, I personally think you're done right here, but it's just kind of satisfying. This is the answer, but it's kind of nice to substitute back in and make sure it's what it's supposed to be as a check. Okay. All right. That's all. Competitive game tonight.